In this example, we're asked to find the volume of the solid formed when the region bounded by y equals x, y equals 2x plus 2, x equals 1, and x equals 3 is revolved around the y-axis. So in this particular problem, no method is specified to compute the volume, but we'll see when we sketch the region and perform the rotation, we'll see that cylindrical shells is the best method to use. So first, let's sketch each of these 4 lines to see what the region looks like. So this is the line y equals x. This is the line y equals 2x plus 2. This is the line x equals 1. And this is the line x equals 3. So this is the region we want to rotate. So if we look at the region and we want to decide how to take a cross-section through the region, it looks like it's best to take a vertical cross-section. So imagine, take a small interval along the x-axis, and I take a vertical cross-section through the region. It'll look like this. Then now we're asked to take this and rotate it around the y-axis. So if I take the cross-section and rotate it around the y-axis, it'll look like this. And we see what happens is this becomes a cylindrical shell. So this tells us we want to use the shell method. Okay, so now we set up the integral. So the shell method is the integral from a to b, 2 pi times the radius times the height times the thickness. So now what we do is we look back at the diagram to figure out each of these 3 quantities. So this is the thickness here, which is given by dx. So the thickness is going to be dx. The radius is this quantity. So it's the distance from here to here. You see that's just equal to x. So the radius is equal to x. The height is this quantity here. The height is just the distance between the green curve and the blue curve. So it's the difference between the two. So the height is equal to 2x plus 2 minus x, or if I simplify this, this is just x plus 2. Okay, so now we're ready to plug everything into the formula. So we see that the region is bounded between 1 and 3. So we compute the integral of 1 to 3, 2 pi times the radius, which is x, times the height, which is x plus 2, times the thickness, which is dx. Okay, so now I multiply the x through and I can pull out the 2 pi. This is 2 pi, the integral from 1 to 3, of x squared plus 2x dx. Now all I have to do is find the antiderivative. Antiderivative is x cubed over 3 plus x squared, evaluated from 1 to 3. So if I plug in 3, it's 27 over 3, which is 9. 3 squared is also 9. When I plug in 1, I get 1/3 plus 1. So this is equal to 2 pi. So if I calculate everything inside the brackets here, I get 50 over 3 And so if I multiply this out, the answer is 100 pi over 3.